Hi lads, in this video I'm going to go through how to do the activities on page 240 and 241 of the Graphics and Design and Communication book. The first one tells us figure 9.33 shows the elevation and plan of a regular hexagonal prism. The solid is cut by the oblique plane VTH. Part 1, draw the plan and elevation of the solid when it is cut by the oblique plane VTH. And then part 2 is draw the true shape of the cut surface of the prism. So for this one you can see the hexagon is at an angle, so we can't actually see the length of any of the sides bar this one here, and we're not actually given that true length. So what we need to do is draw an auxiliary view of that first to get us started. So to start off the question, I'm going to start drawing the actual plan. And I'm going to set that to start at this point here. And I'm told that this point here is 8 mil below the XY line. So I'm just going to take a line straight up there and then take that 8 mil. And there we have our XY line there. I take a line perpendicular to there. It's a length of 75. That's going to go parallel. We don't know the width of it yet, but we can see the height is 60. So what we're going to do is draw the hexagon to fit inside a circle of diameter 60. So I'm going to start that just there. So the width is going to have to be 60 as well to fit inside it. Even though we're not told that we will tell that from what we would have learned in polygons from junior cert. So that's 60 there. We get our 30 there. What I can do now is draw a circle that the hexagon will fit inside. So basically being a radius 30. And all we need to do then is just take our lines using our 30-60 set square then. So take that, move it out of the way there. So we have a 30-degree one that way. And then I'll have to just use sliding set squares again on this way because the camera is going to be in the way if I slide it up the other way. So that's down to there. And this one automatically is going to be parallel to each other. So there we have one length of one of our sides. Because it's actually flat, I'll need to draw it around the 60-degree way instead. So I need to take it this way actually. So this way. And there we have it now, so I use my 60-degree instead. So a bit of messing around, but there's the length of one of the sides. I forgot it was actually not my stars on a point then instead. So we take one length there, mark it there, and obviously this one's going to swing to halfway point there, there, and there. And now we have the true shape of our hexagon. So basically just drew an auxiliary view just to find the true length of the sides because it's tilted at an angle in the plan. So what I can do then is use my 30-degree set square and take back down these lines here and here, and now I can complete my plan. So there's my plan view now drawn, and what I'm going to do is leave it all lightly for now because it's going to be cut. And we can see It's a 45-degree angle for the horizontal trace, and it passes through this corner here. So it's going to be chopping off. All of this guaranteed is going to be cut away. It won't be there anymore. And then the vertical trace actually passes through one of the top points, so I need to actually draw the elevation to get the vertical trace. I'm not given the angle. So what I need to do is take your points up, and it's obviously going to be a total of 60 high, which means the halfway point is going to be 30. And now I can draw in my elevation, and once again I'm going to draw this in lightly for now, as it is going to be cut as well, so I don't know exactly where the cut is going to occur, so I'm going to draw everything lightly. And just that point there is where the trace is going to pass through. So I can draw my vertical trace in there as well. So I have my horizontal trace there and my vertical trace above. And just now draw the hexagon on this side. And that's my elevation now drawn. So to see the cut, what I'm going to do is I'm going to use an auxiliary view. So an auxiliary view is going to help me see an edge view of the cut, which will give me all of my points that I can take back and up into my elevation. And then what I'll do is I'll rabat it back around, just like what's shown in the book. So I'm using an auxiliary and rabatment for this method. So the angle is at 45 degrees. So what I can do is I can extend this out. We can see this as a point. And then my x1, y1 is going to go perpendicular to that. And that should be far enough that I shouldn't go off the page. I just take a little bit lower, just to make sure. So what I'll do is I'll take it about here actually, because I won't interfere with this section then. So there's my point there. That's my horizontal trace. And to find the true inclination, take a random line there, project it up, take that height, knock it off there, and there's my true inclination then of the vertical trace, and I'll be able to see my exact cut then as a result. There's my vertical trace there. And I'll just label that as my x1, y1. So I need to take all my points up now. So first thing I'm doing, I'll take all the ground points up first. Starting on this side here. So those two are on the ground there. And these two are going to be up the 30mm. Then I can take my compass, take my 30mm, mark it out here, and out here. And then also these 2 points are also going to be extended up to give me the top. And they're going to be up 60mm. So from there and there. You can now see where the cut is actually occurring. So everything above that line has been removed then as a result, so we're going to draw that in heavy then after. And the exact same on this side here. I need to extend my x and y1 out a bit further to allow for this bit here. So this bit is going to be up 30mm. This one's going to be on the ground and up 60, so I'm going to have a point there. and then the actual trace itself is going to lie there, and up 60 as well. So take that up the rest of the way, and this one is going to be up 30 mil. So my 30 mil is going to be here and there, and then my 60 is going to be the two center ones again. So here and here. And once again, I can connect those together. And you can see that for this, all of it is going to be cut away. It's all been removed by that plane. So what we see when we actually look in at the this view here, we're going to see all this here. See the line going across there, and then the back surface obviously hidden detail because we can't see this line going across the back there. It's been blocked. And that's all we can actually see in that cut view there. The rest of it you can draw in if you want. It shows in the book it's in hidden detail. You can draw in if you like. Show it's been removed, or you can just leave it in light. So just like in the book, I'll actually just draw it in lightly. Or sorry, with hidden detail. And the last line is there. So basically, just to put it in colour there, all that's actually left is that section there. That's all we've left when we look in as our auxiliary elevation to see our points. So where the points actually hit, I'm just going to label them. So I'm going to say that we have A, B, C and D there. It might be different in the book, I might use letters instead, but the same idea, just labeling it. So A, the cut is going to occur on the ground, and it's going to occur here, and also A is going to occur there, and then on the far side on the ground it's going to occur there. Then B is going to cut along the outside points, so B is going to be here and there, and C cut is going to occur at the front just there, and D, which is on the back surface, is going to occur just there. So we have then, we connect them together. Is that shape there for the actual cut to occur, and I'm just using my 3060. I can draw in the actual remains of it apart from just the cut surface. So all the rest of that is cut away then, because this is going to be on the ground going up, the rest of that has to be cut away as a result. And then we have our hidden detail lines running there on the ground. and then I'm going to leave mine like that, and as a result in the book it may show the hidden detail lines there going the rest of the way around. But you don't need to put that in if you don't want to. We're just showing the actual cut surface here, otherwise it adds a difficulty to the question trying to draw it all in. So in blue, what's left is this section here and here, and then I'm going to use a different colour then for the actual cut, so just green. So I'll show the cut line here in green, and then the actual surface that's cut. And just show once again, just get the colour there, that to get my angle there at this height here, call it H, it's the exact same as this height there, and all I did was looking parallel to my horizontal trace there, just to show that. Now for the elevation, so what the cut actually looks like in it. So A is that first corner there, and that lines up automatically there, and the other point for A on the ground occurs there. When I take B up, B is on the outside point there, and I take B up, it gives me that height there. And C occurs cutting along the line going back in the way. So if I take C up here, it's not really that point there. And then D is on the opposite one there. And all the rest of that is then removed as a result. So what I have is this shape here so far, and then I have a vertex B up as well. B is going to be on this line here as well, so B will connect back into there, and then finally down to A. So C actually makes the round point slightly off there, should be up slightly higher, should be up just like that there, and across, and there we have C now. And then we can draw in then the rest of it that we can see. So everything below here, we can see this. So this is going to be our blue surface on the outside here. We have our line going across here, and then everything else is actually cut away. So we can see actually this hidden detail going back here. It's part of the solid still that remains, and then this part of the solid here going back down to the ground then as a result. And that's part one of the question complete, showing the elevation and plan of the cut surface. So I'm just going to colour in then in blue the actual solid itself, where the cut doesn't occur, so what's actually left of it. And then once again in green the actual cut surface. And that's what we have there then. So the next part then is to actually draw the true shape of the cup of the prism. So basically, what does it look like in terms of looking straight in there at that? So in the book they actually use the rebatment method for this part. You could alternatively take an auxiliary if you wanted as well out that way, but I'm just going to go with what's actually in the book for this question. So for the rebatment, what we want to do is rotate this around until it's flat on the ground. Same idea when we had the idea of the set squares. So the idea is if we have that shape there, it's inclined at an angle. What's the true shape of it? If we rotate it flat down on the ground, we can actually see then the true shape of like that laminar there. When it's held like this, you can't see the true shape. When we flip it back and flat, you can. So what I need to do for this is extend out my XY line there, so I can rotate all my points down. So we can see they're already on the actual plane with the two ground points A and A. So that's perfect to actually start our question off. They're already given to us there, we don't need to change them. So A is already rotated down anyway there at that point. So the next one is going to be B. So we rotate B around, and that hinge point there, where the plane meets, we see there's a point view, so the horizontal trace as a point view. We take that back, perpendicular to this line here, basically same idea as being parallel to the horizontal trace. And we take B out, perpendicular to the horizontal trace there. We get point B here. Now this one will more than likely might go off the page. So I'm going to have B there as well. So we have A and B there. C then. Rotate C around. Take it out there. You can't actually see that if I just tilt this up. There you'll be able to see that now. Take C out. So I need a bit of paper there just for this part. You can see you're tight enough for space actually, even when I tilt it back up. It's close enough to the top of the page as well. So C is taken out. And C hits off this point here. And then D is the last one. My compass and extend D around there. And D will occur just there. And then when I connect those together, it'll give me the true shape of the surface after me rebatting it. So there's the true shape of the cut surface then. And just put it in colour there. And that's the question complete. And just actually for one more thing, just to show how I got one of my points, and I'll leave it like that. Let's take a different colour there, orange. Just show how I got one of my points down there. So for example B, I'm taking it out, perpendicular to our horizontal trace, So that's coming out there. This one will be going down from there. And originates from B, being rebatted out. Like that there. So hopefully that video helps anybody who may have been stuck on that question. It's a tricky enough one to get going, especially drawing the hexagon first and what it looks like then to get the lengthier sides. But once you get that, you should be able to follow it from there. So I hope that video helps.